All right, today we're going to tackle one of the most powerful ideas in all of modern technology. It's the brain behind so much of our daily lives. From our photo apps to our email, we're talking about neural networks.
I mean, think about it. How does your phone instantly find every picture of your dog? How does a self-driving car know that's a stop sign? It really seems like magic, doesn't it? But it's not. The answer is something called a neural network.
So, what is it, really? Well, at its heart, a neural network is a system that learns to spot patterns in data, and it's actually modeled, very loosely, on our own brains. You can think of it like a digital brain that you can teach to understand an image, a chunk of text, or even the sound of your voice.
Okay, so what's actually inside this digital brain? What are the building blocks? Let's peel back the layers and take a look.
It all starts with this one tiny thing, a single digital neuron, sometimes called a node. You can basically think of it as a tiny little calculator. It takes in a bunch of information, decides how important each piece is, and then makes one simple decision. Do I fire a signal or not? It's just a little switch. But here's where the magic happens. When you start connecting thousands or even millions of them together.
So, you take these super simple neurons and you stack them up in layers. The first layer grabs the raw data, like all the pixels in a picture. The very last layer spits out the final answer. But it's those hidden layers in the middle where all the incredible stuff happens. Each layer learns to spot more and more complex things. So the first layer might see edges and colors, the next might piece those together into shapes, like eyes and noses, until a final layer can confidently say, yep, that's a face. And that, my friends, is what we call deep learning.
Okay, so we've got this structure of connected neurons. That's great, but how does it actually learn anything? How does it go from being a complete blank slate to, spotting a cat in a photo? Well, it all comes down to this really powerful but super simple three-step loop. First, it takes a look at some data and makes a guess. Then, it checks its work, comparing its guess to the right answer to see how wrong it was. And finally, this is the most important part. It uses that error to make tiny little adjustments to its connections, so that its next guess is just a little bit better. And it just does this over and over and over again, thousands, maybe millions of times.
It's a lot like learning to play darts. Think about it. Your first few throws, they're probably all over the place, not even hitting the board. But with every single throw, you see how far you missed, that's your error, and you adjust your aim just a little for the next one. A neural network learns in pretty much the exact same way, just through relentless trial and error.
So we get it, the network learns from its mistakes. But hold on a second. When it gets something wrong, how does it know which of its thousands or even millions of connections to actually change, and by how much?
Well, the secret sauce is this really clever algorithm called backpropagation. The best way to think about it is as a system for assigning blame. When the network makes a mistake, backpropagation works backward through all the layers and figures out which specific connections were most responsible for that screw-up.
And to figure out exactly how to make those changes, backpropagation uses a mathematical tool called gradient descent. Now stick with me here. Imagine you're standing on a giant, foggy mountain, and your goal is to get to the lowest valley possible. That valley is the point of minimum error. Gradient descent is like a magical compass that always points in the steepest downhill direction, guiding the network on the fastest path to a better answer.
Look, we're not going to get bogged down in the calculus here, but the big idea is actually pretty simple. The network literally retraces its steps, starting from the final error. It calculates the exact contribution of every single connection to that mistake. Then, it just gives each one a little nudge in the right direction, making sure the next guess is a tiny bit closer to the truth.
All right, so we've talked about neurons and layers and backpropagation. But why should you care? Why does all this abstract stuff matter? Well, because whether you realize it or not, this is the engine that's quietly running a huge part of our modern world.
For starters, you see it every day in classification. That's what lets your phone spot and tag faces in photos, what keeps all that junk spam out of your email inbox, and how your smart speaker actually understands what you're saying. It's all about sorting things into the right buckets.
Then you've got clustering. This is where it gets really cool, because it's all about finding hidden patterns in data without even being told what to look for. It's the reason a streaming service can recommend a show you'll absolutely love, and it's also how your bank spots a weird transaction that just doesn't look like your normal spending habits.
And of course, there's prediction. Neural networks can look at tons of past data to make really educated guesses about the future. We're talking about everything from forecasting when a jet engine might need maintenance to a company predicting when a customer might be about to cancel their subscription so they can step in before it's too late.
So all of this brings us to one last, really big question. We've built this incredible tool that can learn to recognize patterns, sometimes even better than a human can. But does that make it truly intelligent? Or is it just a very, very sophisticated calculator using brute force to hammer its way to a solution through millions of tiny adjustments? Honestly, the answer isn't clear at all. And that very question is what's driving the absolute cutting edge of AI research today.